Hi, this is Andrea Hendricks, and I want to talk to you about how you can use the graphing calculator to graph rational functions and also to find asymptotes and even the end behavior of those graphs. Just some comments before we begin. You want to be careful when you enter a rational function in the calculator. If there is a binomial expression in the denominator, you must use parentheses to enter this, and I'll demonstrate this with a few examples. Rational functions are generally best viewed when you use the z-decimal format, but that does have some limitations. Obviously the window is not going to be very large, so if it doesn't show you a complete graph, you can also use the dot mode to view a rational function. So let's look at a few examples. I'm going to look at y is equal to 1 over x minus 2, y is equal to 1 over the quantity x minus 2, y is equal to 1 over x minus 2 plus 4, and then one of the squared ones, 1 over x plus 2 squared minus 3. So let's look at how we can view the graph, determine some behavior near the asymptotes and also the end behavior, and actually identifying the equation of those asymptotes. So on the graphing calculator, let me clear out this function here. I first want to enter 1 over x minus 2. And let me do this standard window just so you can see what you're going to see. So, that does a pretty good job. You have to understand that this continues. Okay, it's so close to the axis that it can't distinguish the graph from the axis, so it's not going to be able to show that up. So you're going to need to know, if you're drawing this graph by hand, that there is a continuation there. So you would also need to learn that from the graph, there is a asymptote here that's at y is equal to negative 2. Now we can see that if we go to second and graph. Let's look at some things we know. First off, we know that at x equals 0 we get an error. That means it's undefined. So that tells us that the vertical asymptote for this graph is at x is equal to 0. What about the horizontal asymptote? The horizontal asymptote is what's happening as x gets really, really large. So if we go to scrolling down here and determine what's happening as x gets really, really large, we know it should be approaching negative 2, right, because it's shifting that basic graph down 2 units, and to shift 0 down 2 units would become to negative 2. Well, this is being confirmed. You see that as I'm increasing my values of x, the values of y are getting closer and closer to negative 2, but they're not hitting it. That same thing would happen if I approach approach infinity or negative infinity. That is, it would approach negative 2 just from the other direction. So this confirms that at the end, the horizontal asymptote is y is equal to negative 2. But maybe on a test, if you were asked to describe that, you would have to say this: as x is approaching infinity, y is approaching negative 2. Or as x is approaching negative infinity, y is approaching negative 2. Now we need to find out what's happening at and around this x equals 0. So let me go back to my table setup for a minute and start at 0. Okay. Now notice that we have a 0 to 1 and a 0 to negative 1, but we really need to figure out what's happening between those values. And so you can change your table setup if you want to go to your change in table setup. Instead of counting by 1, maybe we could count by 0.1 just to see what's happening. Okay. And so we want to look to see what's happening between, oops, I'm going the wrong direction, I'm sorry about this, between the 0 and the 1. So we see it reaching up to 8, but even understand there's many, many points between 0 and 0.1, right? So why don't we change our table setup to go by, let's start at 0, and let's change by maybe 0.01. Okay, here you can kind of see the effect of it going on. At 0.01, my y value is 98. 0.02, it's 48. So what's happening? As we're getting closer and closer to the value of 0, our y values are getting larger and larger. They're going to infinity. So we would say this, that as x is approaching 0 from the right, y is going to what? Infinity. Now what's happening on the other side of 0? As we're getting closer and closer to 0 from the left side, we're approaching negative infinity. So we would say as x is approaching 0 from the left, y is approaching negative infinity. Okay? So going back to the graph, just to understand that we have a vertical asymptote here and a horizontal asymptote. Now if I draw this graph in the z-decimal format, I think it's a little bit better, a little clearer to see that asymptote. Okay? Let me go back to 1 over x minus 2. Now be careful here. These two look very much alike. If you're not paying attention to this, you might enter the second one as the first one, and that would be incorrect. To make this correct, what I would have to do is put x minus 2 in parentheses, and now we can see the effect of it. Okay, now I changed my format to the z-decimal, so I did zoom and 4 to get that in the z-decimal format, and the graph looks pretty nice. We can see that there is a vertical asymptote at 2. The horizontal asymptote is at y is equal to 0, right, because that's what the pieces are approaching as we go to the right and to the left. But you can confirm that, right, if we do second and graph and look at the table. Let's change our table setup to be back at 0 to begin and just incrementing by 1. Okay, so what we're talking about here is finding out what's happening. In other words, what is our vertical asymptote and our horizontal asymptote. So our vertical asymptote we would find where we get an error message, and that is at 2. Our horizontal asymptote is what's happening as we get really, really large or really, really small. So you can see this x is getting really, really large. What's happening to the y values? They're getting really, really small, right? 0.02, 0.01 something. That's approaching 0. So y is approaching 0. Now let me change my window for a minute. Let's say we were in the standard window. This is what I want to talk to you about here. The graph highlights pixels that are together. In other words, it connects pixels that are next to each other, and so that's why it's connecting these two pieces where really they're not connected at all. So if you want to get that unconnected and not in the z-decimal format, you would have to go to the mode menu and change from connected to dot and press enter. And now we can graph. Okay, now you can see how it draws a graph a little bit more accurately. And so in the dotted mode, it's not going to highlight all those pixels or connect all those pixels. This doesn't really do it justice, I think. I really prefer the zoom 4. Just gives you a better feel for it, but you can do the dot mode if you need to do that. Now how would I enter 1 over x minus 2 plus 4? Well, I've already got the first part of it entered, right? 1 divided by in parentheses, real important, x minus 2, and then I'd have to do plus 4. And graph. Now, this is where the z-decimal window is not going to help us too much, because why? Right, we know we have a vertical asymptote at 2, but we have a horizontal asymptote at 4. And if you look at the z-decimal window, it only goes from negative 3.1 to 3.1. Now here's a neat thing you can do. You can do multiples of these values and still get a good window. Like instead of negative 3.1, I can enter negative 6.2. Oops. And positive 6.2. And graph it. So I can still get a window that's really accurate, just shifting it or doubling it. So here I see that I have this asymptote down at x equals 2, and I have a horizontal asymptote now at y is equal to 4. But again, I can go second and graph, figure out what's happening. So I'm getting really, really large. My values of y are approaching 4. So now my horizontal asymptote is y is equal to 4. And my vertical asymptote can be seen. I start at 0 and go back to the graph or table. I have an undefined or error message at 2, so my vertical asymptote is still at x is equal to 2. Okay. Now, how do I know the end behavior? That is what's happening around the 2. If I want to start at 2 and get really small around that, so 0.01 maybe, and go back to the graph. Yeah, now I can see that as I'm approaching 2 from the left, my values of y are going to infinity. As I approach it from the other side, I'm going to negative infinity. So that just confirms that end behavior we were talking about. So as x is approaching 2 from the right, y is going to infinity. As x is approaching 2 from the left, y is going to negative infinity. Okay. Now to do the next one, to enter this function, I would do 1 divided by, and in parentheses, x plus 2 quantity squared, and then minus 3. So hopefully you know what happens. It says it's shifting left 2, down 3. So if I graph that, okay, there I can see that left 2, so I have this asymptote at 2. X equals negative 2 rather, not 2. And then I have a horizontal asymptote at y is equal to negative 3. So my vertical asymptote is x equals negative 2. My horizontal asymptote is y is equal to negative 3. Again, you can confirm on the graph. Let's go back to changing our table setup to start at 0 and increment by 1. And then go back to the graph or table. Let me get this on here. Okay, so what's happening at negative 2, we should see an undefined message or error message, and we do. Then what's happening as we get really, really large, our values of y are approaching what? Can you see that? Yeah, they're getting very, very close to negative 3. That's what's happening. Okay? So we know that confirms our y-intercept. Now going back to the graph, we can talk about the behavior as we're approaching negative 2 from the right. We're going to, y is going to infinity. As we approach it from the left, y is still going to infinity. And as we approach, as x approaches infinity or negative infinity, y is approaching negative 3. So our end behavior that we can describe, end behavior around the asymptotes is this. As x is approaching 2 from the right, y is approaching infinity. As x is approaching 2 from the left, y is also approaching infinity. And then as x approaches infinity, y is approaching negative 3. And as x approaches negative infinity, y is approaching the negative 3. Okay? So that's how to use a graphing calculator. Let me go back through the window for a minute. If I was at zoom 4, I would see a pretty good window, but I'm almost done at the edge. If I did zoom and 6, what mode am I in here? That was a pretty good picture as well. I'm in the dot mode, so I don't have that connection happening. Okay, so that's a wrap-up of how to use a calculator for these rational functions. If you have any questions, don't hesitate to contact me. Thanks.